Symbols. By the end of this video, you should understand what a data type is, you should know what a symbol is, you should know what variables are, as well as why, when, and how to use them. You should know what constants are, as well as why, when, and how to use them. And you should understand a little bit more about class hierarchies and how to use them in the .NET framework programs. So what language do you speak? We talk about high-level languages in which you have things like the capital letter A and the number 65. Programming languages fall into the category of high-level languages. Then you've got machine languages. This is the zeros and ones that computers speak. In computer language, 01000001 is an ASCII code, and 01000001 in 2's complement notation are both the same number. However, to a computer they can have two completely different interpretations. That means at low level, the first one is the code for the capital letter A, and the second one is the binary for the number 65 that might show up in a program. So data types are a way for computers to disambiguate these objects. In other words, if the computer comes up against a 01000001, then it needs to know whether to put an A on the screen or put the number 65 on the screen, or to use it in a calculation. So data types tell the computer how to interpret different kinds of objects, and they prevent the computer from trying to do nonsensical operations like use the letter A in a calculation. So let's start with some common data types in Visual Basic. There are numeric types like the integer data type. This represents signed integers using a 32-bit memory placeholder. 32 bits is 2 to the 32nd power, different values that can get represented. And in Visual Basic, this is the numbers between negative 2,147,483,647 and positive 2,147,483,648. A single represents a single precision 32-bit number. This is a number with decimal places, and it can represent values from negative 1.401298 times 10 to the negative 45 all the way up to 3.402823 times 10 to the 38th power. So that's quite a broad range of numbers. But if that's not enough, you can use a double, which represents a 64-bit precision number, and it can have values from negative 4.9 times 10 to the minus 324th power all the way up to 1.79 something times 10 to the 308th. And then if you need even more precision, you can use a decimal value, which is a 128-bit number, which can have a lot more significant digits. Then there are non-numeric data types, things like booleans, which represents true-false values, and strings, which represent text values. So how do you choose a data type? All text values, first of all, should be represented as the string data type. Boolean data represents things that can have two values, things like true-false values, yes, no, on, off, up, down, in, out, etc. If you're choosing a numeric type, you first need to ask the question, how much precision do you need? In general, you want to use the data type that requires the least amount of memory or processing capacity. Integers and singles both use 32-bit memory locations. Doubles use 64, and decimal use 128 bits. So if possible, you'll use an integer or single, but if you need more precision for fairly precise calculations, you can use double or decimal. And there are some other numeric types for specialized situations, but if you come up against them, then you'll have to research those on your own. Okay, so what is a symbol? Symbols are signifiers that refer to objects that we're using in a program. And in general, there are two types of symbols, and these are used in almost every programming language. Those are variables and constants. Before we talk about variables and constants, though, I want to talk about naming rules and conventions. So first we have naming rules, and then we have naming conventions. Naming rules are things that are enforced by the computer. For example, in Visual Basic, variables and constants names must always start with a letter. They can use letters, digits, or underscores anywhere in the name except the beginning, which always requires a letter. There are no spaces, no keywords. For example, the word sum, which you might be tempted to use as a variable name, is a keyword which corresponds to a function that gets used in the Visual Basic language. And they have a max length of 255 characters. The names in Visual Basic are not case sensitive, at least not to the compiler. And these rules are all going to be enforced by Visual Basic. So if you violate any of these rules, it will result in a compile time error, and you won't even be able to run your program. Naming conventions, on the other hand, are not enforced by the computer. A naming convention is one that, for example, you would use a meaningful name for your variable. So a bad one would be button 1. A good one would be btn calculate average. The second one, just looking at it, you can tell what the button likely does when a person clicks the button in the program. One of the guidelines that you might want to use for this class is to start all of your variable names with a 3-letter type prefix. That means that the first 3 letters of your variable name correspond to the type of variable that you're using. So for example, common forms and controls that you would use in the GUI interface, a form you might use FRM, for a text box use TXT, for a button use BTN, and then for the basic data types integer, int, double, dbl, boolean, bln, string, str. These types of naming conventions enforced by your instructor, your boss, your manager, your programming team. If you're a member of an open source project, frequently they have style guides that tell you what names to give to your variables and constants when you use them in a program. So let's look at variables. Just think like in algebra, x plus 3. The value of some objects are not known at the time that your problem is posed. In other words, you don't know them ahead of time when a computer program is going to run. Variables are values stored in computer memory that can change during the execution of a computer program. Change, i.e. variable. And they represent things like user input, like the person's name or credit card number, things you don't know ahead of time when the code is being written. When you declare a variable, you have to declare it before you can use it, and it looks like this. There's a dim statement using the dim keyword. Dim stands for dimension, and that creates a dimension of memory in the computer. That's where that keyword comes from. Then you have a meaningful variable name. In this case, int students in debt. This is going to be an integer, the data type, representing the number of students in debt, and then an initial value. Now you don't always have to have an initial value. If you're going to set it later on in your program, you can skip this part at the declaration stage. Here's one for declaring a string variable. Here's the dim keyword. String my name if I had been a girl. That's my variable, meaningful variable name, a string, and then the initial value, again optional, Zoe. In fact, this is what my parents said they would have named me if I had been born a girl instead of a boy. So constants are like variables, but they represent known values, typically ones that are used frequently in a program. Using constants can make your coding easier and improve the readability of your code. The naming convention is slightly different for constants. You're going to use a 3-letter prefix, but then you're going to use all capitals for the variable name and underscores between words. For example, if I'm going to be using pi a lot in my program, I might want to declare it like this. If I'm going to be using Planck's constant in my program, I might want to declare it like this. You must assign a value to the constant at the time that you declare it. You cannot change it at all later on in the program, hence constant. Imagine what kind of coding errors you might have if every time you wanted to do a calculation with pi, you had to type all of those numbers out. If you got some digits wrong, you might have calculation errors that cause things like the warped mirrors in the Hubble telescope. So how do you declare constants? Looks kind of like this. Constant dBl desired salary as double. So there's the constant keyword, which indicates that the symbol to follow is a constant. Use your meaningful constant name, again all caps, with underscores in between words and the 3-letter prefix indicating the data type. Then you have a data type, and then you must have the value. In this case, I'm indicating that my desired salary is $6,530,198.73. Wouldn't that be great? Okay, other data types in VisualBasic.net. Every symbol, regardless of whether or not it's a constant or a variable, and regardless of whether or not it is using one of the basic types like integer, double, or string, has a data type. You can declare variables to have any data type that you want. And here's an example allowing users to open a file. We're going to use the Open File Dialog class as our data type. So you see we have the dim keyword. We have a meaningful variable name starting with a 3-letter prefix, OFD, which stands for Open File Dialog, and then Open Data File, which is what we plan to do with this dialog box. We have the new keyword, which I'll explain in a bit, and then we have the data type, which in this case is Open File Dialog. You'll also notice that I have parentheses there because frequently when you create objects or variables that are not one of the basic types, you need to have those parentheses there to indicate that this is a new object of that type. So let's take a minute to talk about class hierarchies. Other than the basic types, data types are typically referred to as classes and not data types. All classes are derived from other classes, and that means that the classes that are above a particular class in the class hierarchy are known as parent classes. Likewise, below them in the hierarchy are known as child classes. So we have these parent-child relationships. So here's the example of the class hierarchy for the Open File Dialog class, which you used in the last slide. Open File Dialog inherits its properties from the File Dialog class, which inherits its properties from the Common Dialog class, which inherits from the Component class, which inherits from the Marshal by Ref Object class, which finally inherits from the System.Object class. Now you'll notice that each one of these class names has a fully qualified name to it. So at the top we have System.Object, below that we have System.Marshal by Ref Object, System.ComponentModel.Component, System.Windows.Forms.Common Dialog, and as you go down the hierarchy you get more specific, and each time you add a new child class it adds some new functionality to the parent class that didn't exist before. So objects, the mother of all classes. You'll notice that at the top of that hierarchy was System.Object. Visual Basic is an object-oriented programming language. Therefore, every symbol, regardless of whether it's something like Open File Dialog or integer, or Boolean, or string, refers to an object. In other words, every class in VB.NET has System.Object as its topmost parent class. And System.Object does not inherit from any other class. It's the only class that doesn't have a parent. So everything is an object. Classes inherit the methods and properties of their parents. We'll talk about properties and methods in a second. And every symbol inherits the same basic set of methods and properties from the System.Object class. If you take a look at System.Object in the MSDN library, you'll see that it only has a very few methods associated with it and no properties. One of them is the toString method, which will give you a string representation of whatever object you happen to be working with at the time. Now, toString doesn't always give you exactly what you might expect, so you'll need to play around with it when you're writing your programs to see if it gives you something useful. So let's talk about properties and methods a bit. I also refer to these as the nouns and verbs of object-oriented programming. Every class has properties. These are things like name, count, other sorts of properties that refer to static qualities. These are the nouns. And then methods. These are the things that the object can do. So every object has properties and methods. Methods we also refer to further as sub-procedures and functions. We'll cover that in another video later on. You can discover the properties and methods available to a symbol in several ways. You can use the MSDN library to look up the particular object and see what methods it has available to it, what properties it has available to it. You can also use IntelliSense. This is built into Visual Studio, and you'll notice that frequently when you type in the name of an object or a variable and hit the period or the dot, that you'll get a little pop-up window. In that pop-up, you can browse through all of the properties and methods that are available to that class. It's a really great way to explore more about the language and to learn what sorts of things you can do with your variables once you've created them. Finally, there are online forums, places like stackoverflow.com. Sometimes in Stack Overflow you can discover hidden or less known properties and methods, things that are maybe not documented so well in the MSDN library. So let's look at how you declare variables that are of non-basic types. By default, Visual Studio imports a basic set of namespaces that make sure a basic set of classes are available to every program. So the things like buttons and text boxes and forms are available to you when you first create your program, but other things are not going to be available. So if the class you want to use is not part of the default set, you have a couple of options. You can declare it using the fully qualified class name, and that's the class name that starts with system.windows.forms.whatever, or whatever it might be depending on the particular class. Or you can use the imports statement at the beginning of your program, and I'll show you that in a demo a little bit later. You may also need to use the new keyword when declaring a symbol of a particular class. So when do you use the new keyword? This always trips people up when they're getting started with Visual Basic. You want to use the new keyword if you plan to use the symbol right away in the current block of code that you're writing. So if you're going to use it a little bit later, you can avoid using the new keyword, but you might have to use it later on when you actually do use the object. You also want to use the new keyword if the value of the symbol is not going to be assigned by getting it from somewhere else, and we'll have some examples of that in the video as well. Do not use the new keyword if you're declaring a symbol as one of the basic types, so you do not have to use the new keyword for integers, strings, doubles, things like that. And you also don't want to use it if you are declaring the variable in a global scope and will be assigning its value in a more narrow scope. So sometimes you want one of your variables to be available to multiple methods within your class, and so you declare it with a global scope, but then you actually give it a value sometime after the program starts, maybe inside of one of those methods inside of your class, and so in those cases you don't want to use the new keyword when you declare it. You also do not want to use a new keyword if you will assign the value of the symbol by getting it as a property or the result of a method call to another object. I know this is probably a little bit confusing. Watch the rest of the video. There's a demo that shows you how this works in practice. But still, this is one of those things that you really can only learn by experience, by doing some, writing some programs and figuring out when you do and do not need to use the new keyword. It's pretty hard to explain, but it's not so hard once you get some practice using this stuff. Okay, so before we get into the demo, I want to talk briefly about type conversions. Frequently you're going to want to convert a variable or constant from one type to another. As an example, let's say for example that on the form that we're, in the program that we're using, we have a text box where the user is supposed to enter their age. So you can see that on the right hand side of the equal sign here we have txt age.text, and we're using the value in that text box to assign a value to the int age variable. Now int age is an integer, txt age.text is a string. How do you convert a string into an integer so the computer doesn't get confused? You can use this cint or convert to integer function, which takes a single parameter, a string value, which it tries then to convert into an integer. There are a number of built-in type conversion functions like cint, cdouble, csingle, cdecimal, cstring. You can also use the toString method on most of your objects if you don't want to use cstring, and then cbool, which converts to Boolean. For everything else, there's another function called ctype. Here's an example of a program where we have a class called car, and the car class represents things related to a car. On the right hand side here we have a list box, LST cars, that has a list of cars. If we want to get the currently selected car, we can do lstcars.selectedItem, which is the currently selected car in our list, and we want to assign that to the mycar variable that we put at the beginning of the line here. So we're using the C-type conversion function, which converts a list item, right, the selected item in our car list, into an object of type car. So the first parameter in our C-type method is the data that we'd like to convert, and the second parameter after the comma in our C-type function is the data type that we want to convert to. And so this function that this example here would convert that list item into a car variable, or it would try to anyway, and assign that to the mycar variable. You need to be careful when doing type conversions, because converting from one type to another can result in an invalid cast exception. There's an example of that in the demo where if someone tries to type a non-numeric value into the zip code box in the demo, it results in an invalid cast exception, and we catch that and take the person back to the form and make sure that they enter a number. So let's take a look at the programming demo now. Okay, in this demo I'm going to focus on how to declare variables, and I'm going to do so with a little program that I've written to help people find their latitude and longitude based on a U.S. postal address. So here's a little form that I created. It has places for address, city, state, and zip, and people click the Find button. So let's go take a look at the code I've written so far. Here you can see at the top of my program I've got my documentation, which gives me a summary, and then I've got the method btn find click, which pops up the message box with the latitude and longitude when the user clicks the Find button. So let's start by declaring variables for URL, request, response, stream reader, and geocoder data objects. So the first one is the URL that we're going to use, and this is just a string. It's just text. So I'll have dim str for string, URL as string, and we'll say that that's going to be equal to http://geocoder.us/service/csv/geocode/ address equals, and then we'll close the quotation marks. Afterwards we'll put the address, city, state, and zip on there, but we don't know those just yet. Okay, so now we also need the request object, and this is an HTTP request. This is the object you use to get data from a remote website when you're using a Visual Basic program. So dim, and let's call this request, as we're going to make it a system.net.http web request. Okay, you'll notice that system.net.http web request is not one of the basic data types like string or integer, but I did not use the new keyword here because we're going to use one of the static member functions of the HTTP web request class later on to create our web request. Now we need a response. This is a variable to hold the HTTP response, and so we're going to declare that as system.net.http web response. I'm also not using the new keyword here because we will assign the value for the response using the request object. Dim. Now we're creating the stream reader that we're going to need, and I'm just going to call this SR for stream reader as system.io.streamreader. And those are, and then we need one more, which is the geocoder data, which is dim str geocoder data as string. Now, the parentheses that I put on the end of that geocoder data um, variable name indicate that it is an array, and we will assign its value later on once we get the responses back from our HTTP request. Okay, so that's declaring all of our variables. Now, if you look down here, the code below that is designed to make sure that the user entered correct data in all the form fields. So you can see for the txt address box, I'm checking to see if the string entered there is null or white space. I'm also doing the same thing for the city text. I'm checking to see that the state text is exactly 2 characters long, and I'm checking to see that the zip text is exactly 5 characters long. This is the not equal to symbol. So in the case that either of these is null, or this doesn't have 2 characters, or this doesn't have 5 characters, then the user is presented with a message box that says all fields are required. The state should be a 2-letter state code. Zip should be a 5-digit zip code. And then once that they click OK on the message box, then it will just return. It will stop executing any more code in this sub-procedure. And so, it'll take the user back so that they can fix their errors. Second thing I'm checking here is to make sure that the zip code is numeric. So what I'm trying to do here is convert it into an integer. And I just created a variable here, int zip. I'm not actually going to use this int zip anywhere at all. So, but I created it here. If this conversion into integer fails, then that means that they didn't enter 5-digit numeric zip code. And so that exception will get caught. We can show a message box which shows that the zip code must be numeric. It clears the zip code. It puts the cursor in the zip code box so that it can type it again. And then it returns so that it doesn't execute any more code in this procedure. Okay, so that's making sure that our data is safe for us to use. Once we've got it, then we can create the URL we want. So we're going to start with the URL, and we are going to add on to the end of it. The plus equals operator there allows you to concatenate or to add on to the end of the string. And so the way we're going to do that is we are going to say txt address dot text, and then we're going to add a comma between that and the rest of the values. Okay, so now the URL should have the full bit of text that we need in order for us to look up our latitude and longitude. Now we need to create the web request object. So we're going to do that, and we're just going to say request. That variable is going to be equal to system.net.http web request, and that we're going to create, that has a create method that takes a single parameter, the URL that we want to request the request from, and we'll pass it the URL string that we created above. So that will create a HTTP web request object, and we'll pass it to our request variable here. Now that we've got a request, we need to get the response, and so now we say response equals, what we'd like to say is that it is equal to request.getResponse. However, from experience, I've found that the request HTTP request class getResponse method doesn't return the right data type. So we need to use the ctype method to convert that into the data type we want. So we're going to type ctype, and for ctype, the first parameter is the value that you want to convert, and the second parameter is the data type that you want to convert it into. And we want to convert this into a web response. Okay, so that's using ctype to convert the the result of the request.getResponse method into an HTTP web response object. All right, so now we're going to create a stream reader to handle our response so that we can read the data from the HTTP stream that's coming back to us. And so we're saying, let's say SR equals, and since this is a new object we're going to create, we're going to use the new keyword and say system.io.streamReader, and we're going to give it as a parameter the response stream from our response. So we're going to do response.get response stream, and that will show us how to do that. Now, if you're wondering how I know how to do all this stuff with these HTTP requests, basically what I did one day, it's been a while back, what I did one day was just Google, how do you get data from a URL from Visual Basic, and I found a tutorial which, where somebody's code which showed me how to do this. So I'm using code that I'd written or similar to something I'd done before, but the way I figured it out was the same way I would expect you to do it, which is just to Google it and see what you get. Okay, so now that we have got a stream reader which will allow us to read data from an HTTP stream, let's read that into the array of strings that we created above. And so let's go back up and make sure, what did we call that? We called it str geocoder data. And so we're going to say str geocoder data is equal to sr, our stream reader, dot read to end. So this is going to read through all of the values we get back. And it turns out that the values we get back are comma separated values. They are, it's basically going to be a bunch of values separated by commas as one string. And so it's going to read to the end of that stream, and I want to split those values on the comma character. So that'll basically take every bit of data that comes back, and each bit that's separated by a comma will be put into a separate string and then put into our array of strings, which we're storing in this str geocoder data variable. And finally, we can output our message in a message box. So let's do that. Message box dot show, and say something like latitude. And I know from experience that what we want to get here is the str geocoder data, the values in the 0th position in the array, which is going to be the latitude value. And it's a string already, so we don't have to worry about converting it. And then let's add a new line character just so that we can put the longitude on the next line. And longitude str geocoder data, and the value in the 1 position in the array is going to be the longitude. Okay, and that's the data in our message box. And now we can test it out and see if it works. So let's fire it up. Okay, so here's our program. If we click find with nothing in there, it's going to say all fields are required. The state should be a 2-letter state code, and zip should be a 5-digit zip code. So let's go ahead and fix that. Let's say 701 Carrier Drive, Harrisonburg, VA 2280. Let's say G. Let's see. I accidentally put a numeric character instead of let's do this. Let's say I use the letter O instead of the number 0. If I click that, it's going to pop up a box that says the zip code must be numeric. So click OK. So 22807 is our correct zip code. And now we click find, and it comes back with our values, latitude 38.434719, longitude negative 78.863748. And that's what the kind of data we expected. So let's close this. And now let me show you some ways that we can clean up our code a little bit. One of the most obvious ways is you see here we have a lot of places where we've written out the fully qualified name for these variables, system.net.http web request. The reason we're doing that is because the HTTP web request is not a part of the basic classes that get loaded with our program. But we can either type out this every time we want to use something that's in the system.net.http web request area, or we can do something that can make our code a lot shorter. Up at the top of our program, we can add an import statement. And we can say we want to import system.net. And then if we do that, we can go down to our code here, and the system.net namespace is already loaded, so we can get rid of everywhere that it says system.net. And that will greatly shorten our code and make it easier to read. Likewise, we could do the same thing with system.io.streamreader. We could go up here and add another import statement, system.io, and that will get us what we want. So then we can just say streamreader here. And now we go down through the rest of our code and we find all the places where we can have system.net, or where you have system.io. IO stands for input output, by the way. And now you can see that we've shortened our code, made it a lot cleaner, made it easier to read and easier to write. And so you can see the two different ways to import that stuff. All right, so let's save it, and I'll run it one more time just to show you that it works. And there's our latitude and longitude again. All right, so there you have it. You can see creating all of these different variables. You can see use of the new keyword here. You can see that we didn't need to say new, and we had things like strings or integers, and you can see that I wrapped this conversion inside of a try-catch block to catch the conversion from the text data type into an integer data type. So that shows a little bit about data types, shows a little bit about the type hierarchies up here, and I hope that that is going to be useful for you. All right, in summary, most all programming languages use variables and constants as the symbols that get manipulated. It's important to use meaningful names for symbols which follow a consistent naming convention. And you should get to where you understand the class hierarchy in the .NET framework. It'll really make it easier for you to work with symbols. Finally, when in doubt, Google is your friend. I hope this has been useful, and have fun.